This is lesson 6 of Unit 1. The unit is called Functions. The lesson is called Operations with Functions. So what we're going to learn in this lesson is how do we use operations like addition, subtraction, multiplication, and division, and how do they work on functions. And so we can understand, and we're going to learn how to understand the notation around using operations on functions. So kind of a big idea here is like in the past in algebra, we can use letters to represent variables in an equation. So now we can use functions in an equation as well. So to highlight a few examples, we're going to use a couple example functions. So f of x equals x squared plus 5, and g of x equals the square root of x. And so we kind of have 5 properties here. We can do kind of multiplication or addition or subtraction on a function. So like on the output, we can do something to that. Or we could do multiplication, addition, or subtraction in a function. So we change the input values, like in property 2 and 4. So if we let c be just kind of any number, then multiplication on a function means we take the output of that function and we multiply it by something. Or so c of f of x, or c times f of x would be equal to c times whatever the output is. However, if we do a multiplication in a function, we're taking the input and multiplying it by c first, and then doing the rest of the operation. So f of c times x would be c times x squared plus 5. When we're adding to a function or subtracting, so f of x plus c or f of x minus c, then we're just taking the output of that function and then adding that c or subtracting that c to it respectively. When we're doing addition or subtraction in a function, then we're taking the input, adding or subtracting c to it first, and then processing it through the rest of the function. Quick note here, you might have noticed, what about division? We definitely said that we're going to talk about division, divide, but it's not one of our properties here. And so the reason for that is because we can treat division just like multiplication. So if I want to divide by 2, for example, it's the same thing as multiplying by 1/2. So if I use 1/2 as my c value for my scalar, then it's still, you could think of it as multiplication. Sneaky way of, getting one less property we have to learn. So if I think of division as 1 over the number we're dividing by and multiplying it by instead, then I can use these same 2 properties, 1 and 2. Property 5, a function in a function, is kind of something we already hinted at in the last lesson, a function of compositions. So I can put a function as an input for another function. That just means g of x in this example is my input for f of x. And we could simplify some of these here, but we don't need to right now. Let's look at some examples here. So we've given 4 functions to work with, f, g, h, and j of x. Example A says h of g of x plus 5. So we are doing addition inside of the input of g of x, and then that's going to be our input for h of x. So we can write g of x plus 5, knowing that g is the square root of x. We would write g of x plus 5 would be the square root of x plus 5. Since h is x minus 2, and our input is the square root of x plus 5, then our x in our h function is going to be replaced with the square root of x plus 5. So the h of the square root of x plus 5 is going to be the same as the square root of x plus 5 minus 2. And that minus 2 just comes from our h function. Our second example, B, is j of 7 times h of x plus 5. So h of x, the output, is going to be multiplied by 7 and then added to 5. And then all of that's going to be the input for j of x. So first we'll replace h of x. We'll substitute that out for x minus 2. And then we have this expression here as our input for j. We'll simplify that a bit. 7 times x minus 2 is 7x minus 14. And then if we add 5 to that, we'll collect like terms and get 7x minus 9. And 7x minus 9 is going to be our simplified input for j of x. And so j of 7x minus 9, we'll take 7x minus 9 and put it in place of x in our j function. So if j of x is the absolute value of x plus 1, then j of 7x minus 9 will be the absolute value of 7x minus 9 plus 1. Plus 1 coming from the original equation. So now we can get rid of our brackets and we can simplify by collecting like terms. Negative 9 plus 1 will be negative 8. And so now we have the absolute value. So j of 7 times h of x plus 5 is equal to the absolute value of 7x minus 8. Example C, we have f of 3 times x minus h of x. So what we're going to do is we can substitute each function out, because we're just going to substitute them each and then subtract and find the difference. So f of 3x, we'll take 3x as our input for x squared plus 2x, and that'll be 3x squared plus 2 times 3x. And notice the 3x is in brackets, so when we multiply this, or we take the 3x to the power of 2, it's going to be 3 to the power of 2 and x to the power of 2, which will yield 9x squared. We're subtracting h of x, so h of x we'll substitute with x minus 2, and we'll put subtraction between the two. So we get 9x squared plus 6x. We simplify that side, and we'll subtract x minus 2. If we drop the brackets, subtracting x minus 2 is the same thing as subtracting x and adding 2. Think of it as distributing a negative 1 inside the parentheses. We get 9x squared plus 6x minus x plus 2. We collect like terms. We get 9x squared plus 5x plus 2. All right, takeaways for this lesson. We can use functions in equation just like we do variables. We can add to them and multiply them and all kinds of things. And this leaves us with a question. So what is the function? WTF?